So here's my new CNC machine that I just got done building. You can see it's got a Makita router hooked up to it. It's I believe a 1¼ horsepower. I just got done milling these on this very machine. I made some temporary brackets out of steel strap, and then I made these out of this sheet of Delrin here. Anyway, it's belt driven, and I doubled the length of the original design. This is not my design, but the Z-axis is my design. As you can see, I made this 1/4 inch thick plate here, and then it's got a bearing block underneath it, and then it's got this Delrin lead screw nut and a 1/2 inch by 1/10 of an inch lead screw. And let's see, I changed it over to NEMA 23 because I didn't think the NEMA 17s were gonna work for my projects. So it's got NEMA 23, so that's my conversion. There's several similar conversions out there. I'm running it under Mach 3, and so I have a G540 type Gecko drive, and I put it in this single unit rack mount case. It's a portable rack mount case. It has emergency stop, and anyway, I just have a very basic setup. I haven't set up any end stops yet or homing switches. That'll come soon. Let me just power it up for the heck of it. Oh, I don't have it plugged in, so that'll be another time. Anyway, this table, the router table, is a real nice pre-made router table unit, and I'm trying to think of the name of the company that makes it. Incra, I-N-C-R-A. Incra makes this. It's a router table. This is the 36-inch version, and then I have a piece of, I think it's 3/4 inch plywood, and let's see, that's really about all there is to it. This router is available from a company called Inventables, but the version they sell online is $300, and it has half the x-axis length. So I doubled the x-axis length by ordering 1,000mm rails for the side, and it uses these really cool Delrin V-groove wheels, and this is I believe this is called Maker Slide or something like that it's made out of. It's an aluminum anodized, and it has these it's kind of like 80/20 in a way, but it's built-in V-groove tracks, and so with their V-groove wheels and the brackets that they sell and everything, you can put a machine together really easily. This only took me maybe 3-4 hours to put together, other than redesigning the Z-axis. Let me zoom in for the details on the Z-axis so you can look at how that goes. So I have the 2 screws mounted, mounting the plate to the piece of Maker Slide, and every piece of Maker Slide you can tap to receive screws, 5mm by 0.8 screws, and these bearing blocks were pre-made. I got them off of eBay, and so was the piece of lead screw. I believe it's an 8-inch or 10-inch piece of lead screw. It's plenty long for this project, and then so everything just fits together neatly. This bearing block just fits right up against the face of that Maker Slide, and then so you go ahead and look. I didn't do any CAD. I just measured things up and drilled them by hand. And so I like to use blue tape to peg up holes. I'll show that in another video sometime. It's a really easy way to do it. And these standoffs are a piece of tubing, steel tubing that I had laying around. So I cut them into the proper length to give it the spacing it needed for this anti-backlash coupling. So it's a 1/4 inch to 1/4 inch anti-backlash coupling I got off of Amazon. And these are NEMA 23 motors. I get those from a company called Circuit Specialists. They seem to have the best prices, and they don't jack up the shipping costs, and I buy all my stepper motors from them for all my projects. Again, this is my own design of Delrin acetyl type black plastic that's machinable, and it holds this router nice and tight. It's not going to budge. And I did the CAD in a very simple 2D CAD program that's available for free. I'm trying to think of the name of it. eMachine Shop. I use eMachine Shop, then I export it as a .stl from eMachine Shop, and it's real easy to use, kind of like CorelDRAW or something like that, and real intuitive and easy to use, and I picked up on it really quickly. So these are just I think they're 6 or 832 screws. I just had them laying around and stuck them in there. But this is super strong. It's not. These are under no stress. These joint right here is under no stress. It just kind of clamps it together, and because this is so beefy, it's about 4/10 of an inch all the way around. It just clamps down real tight on it. Anyway, that's the end of the video. Let me zoom back out so you can get another overview, so in case I don't trip over something here. So here it all is, and it works great. Thanks.